Hello everyone. In this video, we are going to discuss about algebra of complex numbers. We will be discussing about addition of two complex numbers in this video from the chapter 4, class 11, Max, complex numbers and quadratic equations. You see, we will be discussing about the other algebra of the complex numbers like difference, multiplication of two complex numbers, division, etc. in the next videos, which will be available in the playlist. So here we are going to discuss about addition of two complex numbers. So for that, I am considering two complex numbers. One is z1 is equal to a plus ib and z2 is equal to c plus id. See, a is the real part of this complex number and ib is the imaginary part. And here c is the real part and this term, that is for the imaginary part. So here you see, when we take the sum of these two, addition means sum, no? So z1 plus z2 will be equal to a plus ib plus c plus id. So I am writing this a and c together. So a plus c plus I is common in these two terms. So I into, we can write b plus d. Okay. So here you see, we can write it as z1 plus z2 is equal to a plus c plus I into b plus d. Okay, so you see, this is how the addition of two complex numbers is defined. See this a plus c, this is the real part of this, and I into b plus d, no? So this b plus d, which is the imaginary part of this number. Okay, so you see, this is again, that is a sum z1 plus z2 of two complex numbers. That sum is again a complex number. That is, when you add two complex numbers, the sum will be a complex number too. For example, let us consider a complex number z1 as 2 plus I into 3. So you see, 2 is the real part of this complex number, 3 is the imaginary part. Then I am taking another complex number z2. This z2 is equal to minus 6 plus I into 5, where minus 6 is the real part and 5 is the imaginary part. So when we add these two, z1 plus z2, and you see how this addition of two complex numbers is defined, you just want to add the real part of the complex numbers plus I into add the imaginary part of the two complex numbers. So here real part is 2, here minus 6, so 2 plus minus 6. Okay, plus I into add the imaginary part of the two complex numbers. So 3 plus 5. Okay, so here we can write it as z1 plus z2 is equal to 2 plus minus 6 plus minus becomes minus. So 2 minus 6 minus 4 plus I into 5 plus 3, 8. So you see, this is how we add these two complex numbers. And you see, the addition of complex numbers satisfy the following properties. The first one, the closure law. That is, the sum of two complex numbers is a complex number, which we have just seen. We have just considered two complex numbers z1, which is 2 plus i3, and z2 minus 6 plus i5. When we added these two, we got the sum as minus 4 plus I into 8, which is again a complex number because it has a real part and an imaginary part. So you see, according to this first property, closure law, the sum of two complex numbers is a complex number. That is, for any two complex number z1 and z2, their sum, which is z1 plus z2, is again a complex number. Okay, now the second property is the commutative law. That is, for any two complex numbers z1 and z2, z1 plus z2 will be equal to z2 plus z1. That is, for real numbers, we know that for real numbers 2 plus 3, that is equal to 5. That is actually equal to 3 plus 2 as well. 3 plus 2 is also 5. So for real numbers, you can write 2 plus 3 is equal to 3 plus 2. Similarly, for any two complex numbers, we can write z1 plus z2 is equal to z2 plus z1. Okay, now the third property is the associative law. That is, for any three complex numbers z1, z2 and z3, z1 plus z2 plus z3 will be equal to z1 plus z2 plus z3. That is, you can just add the first two complex numbers, then add the sum of these two with the third complex number. You will get a complex number as a result. Or you can add the second and third complex numbers together first, then their sum is added to the first complex number. That result will be the same as this. Okay, that is for real numbers. We know that 1 plus 2 plus 3. This is actually equal to what? 6, no? 1 plus 2, 3. 3 plus 3, 6. This is also equal to 1 plus 2 plus 3, right? Because 2 plus 3 is 5. 5 plus 1 is 6 again. Okay, so for any three complex numbers, we can write z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. Now, the fourth property is the existence of additive identity. That is, there exists a complex number 0 plus I0, where 0 is the real part and here imaginary part is also 0. So, there exists a complex number 0 plus I0, which is actually denoted as 0. Okay, this is actually called as additive identity or zero complex number. So you see, 0 is the additive identity in complex number such that for every complex number z, when you add this additive identity with that complex number, you will get that complex number itself. Okay, z plus 0 will be equal to z, then 0 is the additive identity or zero complex number. That is for real numbers. We know that 2 plus 0 which is equal to 2. So 0 is the additive identity for a real number. Similarly, 0 is the additive identity for a complex number. But here this 0 is actually what? 0 plus I0. Okay, now the fifth property is the existence of additive inverse. That is, to every complex number z is equal to a plus ib, there is a complex number minus z. Minus z is actually equal to minus a plus I into minus b. Okay, so such that z plus minus z is equal to 0. Then this minus z, it is actually called as the additive inverse or negative of z. Okay, minus z, that is actually called as additive inverse or negative of the complex number z. Okay, that is, you see, for real numbers, we know that if you consider a real number 1, then when you add minus 1 with it, you will get 1 plus minus becomes minus, then 1. 1 minus 1 is equal to 0. Okay, so minus 1 is the additive inverse of 1. Similarly, minus z is the additive inverse of z. Okay, or for example, you can consider a complex number z as 2 plus I3. There exists another complex number minus z, which is actually called as additive inverse of this z, which will be equal to minus 2 plus I into minus 3. Okay, so you see, this can also be written as minus 2 plus minus becomes minus I3. Okay, both are the same actually. Now, when you add these two, that is z plus minus z, this will be equal to 2 plus I3 plus minus z is actually what? Minus 2 plus I into minus 3. Okay, this can be written as 2 plus I3 plus minus becomes minus 2 plus plus, so plus itself I into minus 3. Okay, and you can write it as 2 minus 2 together, 2 minus 2. I is common in these two terms, so plus I into, here we have 3, here we have minus 3. Okay, so this is actually equal to what? 0 plus I into 0, 0 plus I0, which is actually equal to 0. Okay, that is, to every complex number z is equal to a plus ib, there is a complex number minus z, which is equal to minus a plus I into minus b, and z plus minus z is equal to 0, and this minus z is actually called as additive inverse of z. Okay. So in this video, we have discussed about the algebra of complex numbers, that is addition of two complex numbers. We will be discussing about the division of two complex numbers, multiplication, difference in the next videos, which will be available in the playlist. Thank you.